Lesson 6-6, Solving Radical Equations. A radical equation has a variable in a radicand. When solving a radical equation, the result may be extraneous solution, which just means that you could get a solution, but if you put it back into the original problem, it will not make sense. The steps to solving radical equations. Step 1, isolate the radical on one side. So get the radical by itself. To eliminate the radical, raise each side of the equation to a power equal to the index. So if you have a square root, you square that side. If it's a cube root, you cube that side. In step 3, solve the resulting polynomial equation and check your results. So the first example, to get the radical by itself, I'm going to subtract 2. Now I have the square root of 3x minus 5 equals 4. Now the index is 2, so to undo a square root, I have to square both sides. So this will give me 3x minus 5 equals 16. Now I solve for x by adding 5 to both sides, and I get 3x equals 21. Divide by 3, x would equal 7. Now if I put 7 back in to my equation, so I have 3 times 7 minus 5, then I add 2. This has to equal 6. So 3 times 7 is 21. 21 minus 5 is square root of 16. Square root of 16 is 4. 4 plus 2 is 6. Now when you check your work, you always use the positive root. So the positive root of 16 is 4. So I know my answer would be 7. Next, solve this one. You see a rational exponent. This means the same thing as half. So I'm going to get that by itself. So I'm going to add 5 to both sides. And now I'm going to rewrite this so it's a radical. So this would be the square root of 6x plus 21 equals 3. To undo a square root, you square both sides. And I have 6x plus 21 equals 9. Subtract 21, and now I have 6x equaling a negative 12. Divide by 6, x would equal a negative 2. Now if I check that, in here I would have 6 times negative 2 plus 21. All of this I have to raise to the 1/2 power or find the square root of it. Subtract 5, and that should give me negative 2. So negative 12 plus 21 gives me 9. And the square root of 9 is 3 minus 5 will give me negative 2, which does equal negative 2. My answer is negative 2. Example 2, we have cube root equations now. So we're doing the same thing. Now here, to get the radical by itself, I'm going to add 9. So now I have 4 times 2x plus 6 raised to the 1/3 power. I'm just going to keep the exponent on here. Equals 12. Divide everything by 4. And now I have 2x plus 6 raised to the 1/3 power equals 3. Now to undo 1/3, I have to square both sides, or not square both sides, but cube everything. This cube gets rid of that 1/3. So now I'm left with 2x plus 6 equals, I got to cube to 3, gives me 27. Subtract 6, now I'm left with 2x equals 21. Divide by 2, x would equal 21 halves, or 10.5. Actually, not 10.5. Yeah, 10.5. Now to check this, plug that back in. So I have 4 times 2 times 10.5, and then plus 6. Need to find the third root of that, and then minus 9. This should equal 3. So this would be 10.5 times 2 gives us 21, plus 6 gives us 27. The cube root of 27 is 3. 3 times 4 is 12. 12 minus 9 gives us 3, which does equal 3. So our answer, 21 halves, or 10.5. Another one with cube roots. Here we're going to subtract 8, and I have negative cube root of 4x minus 1 equals negative 3. Divide by negative 1. So now I have a cube root of 4x minus 1 equals 3. Cube both sides, and now I have 4x minus 1 equals 27. Add 1 to both sides, and I get 4x equals 28. Divide by 4. X would equal 7. Check it. So negative cubed root of 4 times 7 minus 1 plus 8 equals 5. 28 minus 1 is 27. Cubed root of 27 is 3. Times the negative 1 is negative 3 plus 8 gives you 5. So 5 does equal 5. Example 3, identify extraneous solutions. So these, when you solve it, there's going to be an extraneous solution, so we need to check our answers when solving them. So you notice that we have radicals on both sides here. When we have radicals on both sides, we want to square one of the sides first, the one where the radical is by itself. So if I square this side, that gives me x plus 21. But now I have to square this side, which is a perfect square trinomial. That will give us 9 minus 2 square root of x, or not, negative 6 square root of x, because 3 times negative square root of x is negative 3 square root of x, and we have 2 of those, and then this would be a plus square root of x times in the square root of x gives us x. Now from here, we're going to get everything away from the radical, so I need to subtract x and subtract 9 on both sides. Subtract x, subtract 9, and now we're left with 12 equaling a negative 6 square root of x. To get the radical by itself, divide by negative 6. I have a negative 2 equaling the square root of x. To undo a square root, we square both sides, and we get x equaling 4. So if I put that back in to see if that makes sense. So I have the square root of 4 plus 21. That has to equal 3 minus the square root of 4. Here gives me a square root of 25 equaling 3 minus 2, which will give us 1. And on this side we have 5. 5 cannot equal 1. Therefore, there is no solution that will make this true. So the extraneous, this 4 is extraneous, which means we did get a solution, but when you put it back in, it doesn't make sense. So answer for here is no solution. Next, square this side, square the right side. So we have x plus 32 equals, this would be 4 minus 4 square root of x plus x. Subtract 4, subtract x. Now have 28 equals the negative 4 square root of x. Divide by negative 4. And now we have negative 7 equals the square root of x. Square both sides, and we get x equaling 49. Now if we check it, we have the square root of 49 plus 32. This should equal 2 minus the square root of 49. 49 plus 32 gives us 81, so square root of 81 equals 2 minus 7. This is 9 equals a negative 5. They are not equal, so there is no solution. Our extraneous solution would be 49. Example 4, solve a radical equation here. Okay, so I need to get the radical by itself, so I'm going to subtract 8. This gives us 2/3. And I'm going to make this the 6th root of 11x plus 14 equals 2. To get the radical by itself, I multiply by 3/2. And now I have the 6th root of 11x plus 14 equals 3. To undo the 6th root, I raise it to the 6th power on both sides. This will give us 11x plus 14 equals the 6th root, or 3 to the 6th power, would give us 729. Subtract 14, 11x equals 715. Divide by 11, so 715 divided by 11 gives us 65. So x would equal 65. If we plug that back in to see if that works, so we have 2/3 times 11 times 65 plus 14 raised to the 1/6 power, add 8, that has to equal 10. So 11 times 65 is 715 plus 14 is 729. Raise that to the 1/6 power. Gives us 3. 3 times 2/3 gives us 2. 2 plus 8 is 10. 10 does equal 10. So our answer is 65. Another one, add 2 to both sides. So we have 3 times the 5th root of 4x minus 8 equals 6. To get the radical by itself, I divide by 3. And I have the 5th root of 4x minus 8 equaling 2. Raise everything to the 5th power. And now I have 4x minus 8 equals 32. Add 8. And now I have 4x equaling 40. Divide by 4. X would equal 10. To check it, be 3 times the 5th root of 40 minus 8 minus 2. This has to equal 4. This would give us 2 times 3 gives 6 minus 2 has to equal 4. This is 4. 4 does equal 4. So our answer is 10. Next part of our lesson, solving radical equations by graphing. So to solve a radical equation using the graph of a related function, rewrite the equation with 0 on one side and then replace 0 with f(x). So the equation square root of x plus 5 plus 1 equals 4. You can rewrite that by subtracting 4 on both sides and get square root of 2x plus 5 minus 3. The values of x for which f of x equals 0 are the zeros of the function and occur at the x-intercepts of the graph. So the solutions or roots of an equation are the roots or x-intercepts of its related function. You can also solve a radical equation by writing and solving the system of equations based on the equation. So if you take that same two equations and write it as two separate ones, y equals the square root of x plus 5 plus 1, and the other one is y equals 5. The x-coordinate of the intersection of the system of equations is the value of x where the two equations are equal. Thus, the x-coordinate of the point of intersection is the solution of the radical equation. So, use a graphing calculator to solve 2 times the cube root of 3x minus 4 plus 10 equals 9 by graphing. So, grab our calculator. So put that here so we can see the equation. So we'll clear everything here. So we got 2 cubed roots of 3x minus 4 in parentheses. Here I'm going to do, I'll subtract 9 on both sides and then I get plus 1 here. So we'll just do it with 1 here and then I'll show you how to do it if you did 2 separate ones. So now if I graph it, you can see my cubic function here. I need to find out what this point is. So I go second, trace. I need to find the 0, number 2. Hit enter. Above the line, hit enter a third time, and it'll tell us 1.29. Now the other way would be if I did one, make this 10, and the other one, y equals 9, and then graph it. Here's one equation. Here's the other. I want to see where does it cross here. So I do second, trace, intersect number 5, hit enter 3 times. It'll give us the same answer of 1.29. So we would say that x would have to be about 1.29. Going on to the next one, use a graphing calculator to solve this one by graphing round to the nearest hundredth if necessary. So for this one, we'll just do it as one equation to make it easier. So I have -5. Now we have to do it to the fourth root. So I'm going to do parentheses 2x minus 3 and parentheses, and I'm going to raise it to parentheses 1 divided by 4 and parentheses, and then it's going to be plus 7 because I'm subtracting 6 on both sides. Now if I hit graph, see that it crosses here, so I hit second, trace number 2, the 0. Left bound would be here above, right bound below. Enter, hit enter a third time, and we should get 3.4. So x is about 3.42. Example 6, in 1619, German mathematician and astronomer Johannes Kepler published his third law of planetary motion. This states that the square of the time it takes a planet to orbit the sun, t years, is equal to the cube of the planet's mean distance from the sun, a, measured in astronomical units, also known as AU. It takes Mars 1.88 years to orbit the sun. We need to write and graph the function and then interpret the solution in the context of the situation. Is your solution viable? So part A, write and graph the function, says the square of the time it takes the planet to orbit the sun is equal to the cube. So let t represent the time in years. So the square of the time, so this would be t squared, and let a represent the planet's mean distance from the sun in astronomical years, is equal to the cube of the planet's mean distance. So this would be a cubed. Now, if we want to solve for time, I would just have to find the square root of both sides, and that would give us t equals the square root of a cubed. Or you could also write it as a to the second, a to the 3 halves power. Either way would be an appropriate answer. Now it says that it takes Mars 1.88 years to orbit the sun, so we can write that as the time. So let's go over here. We have t equals the cubed root, or not the cubed root, the square root of a cubed. If the time was 1.88, we can now solve for this one. So we can have two equations. We can have one as y equaling 1.88, and the other one is the cube or the square root of a cubed. So instead of graphing it on a number line, on a coordinate plane, we could do it. 1.88 would be roughly here, and then the cube root of, or the square root of a cubed, that would be easier just grabbing our calculator. What are the y equals? First one, we have 1.88. So put that one down, and the other one, the square root of x cubed. Now if I graph those, here's your 1.88, and then the other one is here. So if I do second graph, come up with some points here. We can do 0, 0. So I'll do in blue. We have 0, 0. We have 1, 1. We have 4, 8. 4, 8 would be way up here. So it looks something like this. We want to find out where do they meet. So if I go back to my graph here, do second, trace, need to find the intersection, number 5, hit enter 3 times, and it tells us 1.52 is roughly where they meet, so that would be 1.52. That would be our x, and our y would be at 2. So is that a viable solution? The solution is viable because the graphs of the function appear to intersect at that point. Now, part B, interpret the solution in the context of the situation. We did say it's viable. Here we're going to solve it algebraically. To solve it algebraically, I'm going to square both sides. So 1.88 squared would give us 3.5344 equals a cubed. So when you do a cube, you find the cube root of both sides, and the cube root of 3.5344 equals roughly 1.52. So the interpretation says the mean distance from Mars to the Sun is about, this is about 1.52 astronomical units from the Sun. And our last question, the harmony clock in the province of China is the world's largest pendulum regulated clock. The time t in seconds for a pendulum to swing back and forth can be found using the formula 2 pi times the square root of the quotient of the length of the pendulum L in feet and 32. The pendulum of the harmony clock takes 4 seconds to swing back and forth. Part A, write and graph and use graphing calculator to graph the function. And part B, interpret the solution in the context of the situation. Is your solution viable? So the first thing we need to do is come up with our function. And it says the time t in seconds for a pendulum to swing back and forth can be found using, so we're going to have t using 2 pi times the square root of the quotient, so the square root of a division problem, the length L divided by 32. So that would be our function here. And then we are going to find out the pendulum of the harmony clock takes 4 seconds to swing back and forth. So my other one is going to be y equals 4. So if I take my calculator here, We'll put both of them in. So the y equals, clear this one, we'll put a 4. The other one, clear. We have 2 pi, so 2 seconds, caret to get the pi in there. Then we have the square roots of, we're going to do x divided by 32 and parentheses. Now if we graph this one, here's the 4, and then the other one. Can't see quite off where they meet, so let's change our window settings. Our x maximum, let's make this 20, and let's hopefully we can see that here. Okay, we need to find out where do they meet, so second trace number 5. Hit enter. Gives us 12.97. So t would be roughly 12.97. This would be in seconds. Or the length, w. So we're trying to find the length. So the length would be roughly 12.97 feet. Now if we're to solve this algebraically, I would have 4 equaling 2 pi times the square root of L over 32. Divide everything by 2 pi. So I would have 2 divided by pi equals square root of L over the square root of 32. So to rationalize this, multiply by the square root of 32, square root of 32 here. This will give us 2 over pi equals square root of 32L all over 32. Multiply by 32 on both sides. This gives me 64 over pi equals the square root of 32L. Square both sides, so I square this. So now on my calculator, I'm going to do parentheses 64 divided by second. Caret symbol, put the pi in there. I'm going to hit square. I get a really long decimal, and my last step will then be to divide by 12, or not 12, by 32, and you still get to your 12.96. So interpret that we just said was the length of the pendulum is about 12.97 or 12.96 feet. So that's our lesson on solving radical equations.